0, which is equals to p minus p, simple pH. So you can see these terms are also involved everywhere in the whole polynomial. So we can replace those with pH. But still there are some other terms involved. We have to replace them accordingly. Okay. Now to replace x1, we know the formula for x1 is x0 plus h. Okay. From here, this part, you can find out this x0 on shifting this on the left side. So we'll be getting x minus pH, which is equals to x0. So this x0 can now be replaced by x minus pH plus h. Okay, I repeat it. Okay, here you have x0. I have shifted this on the left side. Let me do this work here. Here we get x0 equals to x minus pH. So I have substituted x0 over here with this, and we got this result. Now this can be further written as x minus, if I take out h as a common factor, from here the result takes the form like that. And on shifting this quantity on the right side and this quantity on the left side will give you x minus x1 is equals to p minus 1 times h. So now we got another result which can be replaced everywhere where there is x minus x1. So now we have two replacements. One of them is x0, x, which is equals to x minus pH. So I can replace all this by pH over here. Over here. And second one is this one. And similarly, if we want to write down the results for the remaining terms, so those can be written as simply x minus x2. That can be equals to now p minus p1, p minus 2 into h. And x minus x3 can be replaced by p minus 3 times h, and so on. You can proceed on the same pattern and you can get the replacements in terms of p. So after knowing all this, now I'm going to make a change here. So this quantity x minus x0, I'm going to replace it by simple, you can see here x minus 0 pH. So this can be replaced by pH. And from here, from the second term, this will be replaced by pH only, and this will be replaced by p minus 1 times h. So these two terms are also going to be replaced by p. So first term is p times h, and second is p minus 1 times h. And if we proceed on the same lines, so the other terms can also be replaced on the same pattern. So here it is pH, p minus 1 times h, and p minus 2 times h. Okay, and you can similarly write the replacement for this term. I'm going to erase it just to simplify your work, and we can just take it as and so on. No need to write down the last term. So here, whenever we further simplify it, on further simplifying, we'll be getting the ultimate result of y equals to y0 plus, if you can see, these h can be dropped down, this h cube will be dropped down with these, and h cube will be dropped down with all these h. So there is no more h into the formula. So the result takes the form y0 plus p times del y0 plus p into p minus 1 over 2 factorial del 2y0 p minus 1 p minus 2 over 3 factorial del 3y0, and so on. So this becomes the ultimate formula, which is named as the Newton's forward difference interpolation formula. And one more important thing is, this formula will be only completed when we know the value of p, and p is obtained by using the formula of x minus x0 over h. And where it is coming from, if you remember, we have just substituted x equals to x0 plus p times h. So on simplifying, I got the value of P in the form of x minus x0 over h. So this is your first formula, which we known as, of course, the Newton's forward difference interpolation formula. So after knowing this formula, I'm writing now the second formula directly without giving you the proof, because the proof is exactly on the same lines. There is nothing new is there, except only there are few changes into this formula. So just note down the changes. Okay, what are the changes into the second formula? And second formula is named as, let me give the title, Newton's backward difference interpolation formula. So this is the formula parallel to the in the previous case. This was the forward difference interpolation formula, and you can note down the operator which we have used here, and that is the forward difference operator. And if you have seen the lecture on operators, so you must remember how actually this operator works. And now we are using the backward difference interpolation, so there will be of course slight changes. So let me make a space here to write the formula directly without writing the proof. The formula can be generated from this formula without any proof. How we can write down the formula? So you have to make two changes. One of the changes is you have to replace the operator. Operator will be, due to the backward difference, we should be using the backward operator, which is nebula. And second change is you have to replace all the minus here with the plus sign. And there are two more changes. I'll let you know after that. And these are okay. So far we have obtained the forward difference interpolation formula, and after knowing this formula, we can write down the second formula of the Newton's backward difference interpolation directly from this formula. So here let me write down the formula which is the Newton's backward difference interpolation formula. So the title is Newton's backward difference interpolation formula. So this is the title of the second formula. Only the difference in between the title is the forward and the backward. And forward is due to the operator which we have used. Now we are using the backward, means we have to make the change in the operator as well. So there are a few changes we are going to make or introduce into this formula in order to write down the formula directly. So I am writing the formula for this backward difference interpolation over here. Okay, so note it down. So here we write down y is equals to yn. So all the y zeros will be replaced by yn, first change, plus p into delta. All the forward difference will be replaced by backward difference, and those are shown, if you remember, while studying the operator. So we have shown it by the nebula. So nebula yn. Next is p into p minus 1. So p minus 1, and all the minus will be replaced by with the plus sign. So this is the another change. Now the next term will be nebula yn plus p into p plus 1, p plus 2 over 3 factorial, and nebula 3yn, and many more terms you can write down. So this is the formula. If you compare these two formulas, there are only few changes. First change is the change in the yn in place of y0, and second, plus are replaced with the minus sign everywhere, and the change of the operator. So these are the few changes, and the next change is into this formula, because we also require the value of p. So here p is equals to x minus xn over h. So now this is the second formula, which is named as the Newton's backward difference interpolation formula. There are few important things you have to keep all these things in your mind before start solving the question by using these formulas. The first thing is that these formulas are generated for a given set of points which are assumed to be equally spaced. Means in between the distance in between any two points remains the same throughout the set of points. This is most important. And second, you have to keep this thing also in your mind, that these two formulas are applicable for different situations. And what are the two different situations where we can apply these two formulas? One of them is a forward difference interpolation formula will be used whenever you are looking for a value which is lying close to the initial set of points. And second formula is applicable whenever you are using whenever you are looking for a value which is close to the endpoints. So these are the few differences in the utilization of these formulas. In order to further elaboration of this concept, let me write here simply to tell you how actually we can understand which formula you have to use for different locations or different situations. Suppose we are provided a set of points in the form of x and y, okay, and I'm just taking it for granted to create a differentiation in between the application of the two methods. And we are provided a set of points, say in the form of 1, 2, 3, 4, 5, 6, 7, and there can be more points as well. Now, if you are looking for a value which is close to the initial point, suppose we are looking for a value 1.3, which is although not present within the given set of points, but within the range of the points. So here we shall be using the forward difference interpolation formula, because the value which we are looking is lying close to the initial set of points. Similarly, if any value is somewhere here, says we are looking for a value 6.1, which is close to the endpoints. So in such situation, we'll be using the backward difference interpolation formula. Now here immediately arises a question, and definitely it can arise in your minds as well. Whenever we are looking at a value lying close to the center of the given set of points, in the middle of these points somewhere, then how we can interpolate? So in such cases, we have another formula which we generally known as the central difference interpolation. And this is also available in literature. You can go through some good books on the subject and you can find out the proof as well as the application of that formula there. But for your examination point of view, we shall be restricting ourselves only to these two formulas of the forward difference as well as the backward difference. Okay, after knowing all these informations, now the next step is to apply these formulas on solving a question. So here we start solving a question. Okay, here we are provided a set of points, and the set of points are of course in the form of x and y, and the values of x are 8, 10, 12, 14 and 16, and the corresponding values of y are 1000, 1900, 3250, 5400 and 8950. And the requirement is you have to calculate y for x is equals to say 9. Okay, so this is the question, and we are required to find out the value at x equals to 9. And you can see here the value at x equals to 9 is not present within the given set of points, but of course it is within the range of the set of points. So from here, from this information, it is directly understandable which formula you have to use, because x equals to 9 is close to the initial point. So this indicates we have to use the forward difference interpolation. So sometimes it is provided in the question you have to use this formula, and sometimes it is not provided. So on the information given in the question, you can understand which formula is most suitable to apply to find out the required solution. So here now we start solving this question. So in order to start solving this question, so from here you can see x0 is equals to 8. You can see your x0. This is your x0. And x is equals to 9 from here. And h we can obtain the